Welcome students, welcome to the next class of physics. Today we are going through vectors, and as we know, the major difference between scalars and vectors is that vector basically is having its own laws of addition. As scalar you can add it mathematically, you can use a simple mathematics rules, okay, but vectors are definitely going to have some kind of different rules for themselves, okay. So that is why we are going through the first law, the triangular law of vector addition. And again, if some students are new to that channel, so you can subscribe that channel as well for the more study videos, okay. And don't forget to press the bell icon to all, because that can give you the notification free of cost, okay. So today, first of all, we are going through the statement, the triangular law of vector addition statement, okay. If we can represent two vectors, so this is our first vector. Obviously the vector is going to have some kind of direction, and another vector is we are going to take like this. So if we name those vectors, so we are just naming those vectors as A vector and B vector. Now these two sides are in same order. Now what it means, the vector is always drawn from tail to head. The arrow part is always going to be a head part. The vector is always written in this format as well. It is always written in from tail to head format, okay. And this is our vector A, and again from it is starting like in same order, which means tail to head and again tail to head. And if these two sides are represented by the sides of a triangle, and if we are going to have a third side, so making that triangle complete, obviously the triangle is going to have three sides, okay. So two sides are in same order and the third side is in opposite order. So then this closing side, which because that is in opposite order, that is going to be the resultant of that, and we can write it like that. This can be sum of the two sides which are taken in same order. And that can also be taken as a statement of triangular law. Now what it state? Obviously if you want to write the statement. So if two sides of any triangle taken in both magnitude and direction by the two sides of triangle taken in same order, and if the third side is representing as a closing side which is in opposite order, then the third side is going to give you the resultant, which is going to be equal to sum of the two sides. So that is a very simple triangular law of vector addition statement for you. Obviously triangle is having three sides, two sides in same order, third side is which is in closing order, opposite order, that is going to be the resultant, okay. But this topic is not going about only the statement of that thing, okay. We have to calculate the magnitude of that resultant. For that we have to make a topic and we have to give some kind of construction to that diagram as well. So I'm just going to add some construction to that with the new points. So I'm just erasing that, and we are going to make a new diagram to prove the magnitude, and that topic is known as the analytical method to calculate magnitude of resultant of triangular law of vector addition. So I'm just going to take same triangle here, okay. So nothing to worry. So I'm just going to have the same triangle here. So this triangle can be marked as PQ, okay. So this is going to be okay. So this is our triangle. Now we are going to have some kind of construction here. We are just dropping a perpendicular from here, okay. So you can mark that as P and that can be marked as Q. So I'm just taking points here A, B, C and D. Obviously we have to mark the directions because this is vectors topic. Without direction that diagram can be wrong. So you have to mark the directions here. Now I am going to use a simplest of thing here, okay. So just taking that angle as theta and that angle as alpha. So I'm going to solve it by the Pythagoras theorem. As you know, you have gone through the Pythagoras theorems in 10th class, so it's very used to, everybody is very used to that, and everybody know about the Pythagoras theorem. So I'm going to solve this topic by the Pythagoras theorem. So which means we are just going to take a triangle, a bigger triangle, that is ACD. Okay, I'm just applying Pythagoras theorem here. So that is going to give you AD square is equal to, yes, AC square plus CD square. So you know what is AC? AC is sum of AB plus BC. So we can mark that AC as, so that is AD square. It can be marked as, now this is AB plus BC square plus CD square. So this is going to be your equation, okay, and this is marked as question number 1. And as you know, what is AD? AD is marked as resultant, so that is marked as R. So we have those values. So AD is marked as R, AB is marked as B, and BD, that all is in construction, okay. Now we have those values, but we are not aware of the value of BC and CD. Now BC and CD, how we can calculate that? For that we have to go through a smaller triangle, that is going to be, I'm just writing it here, so smaller triangle, that is going to be BCD, that is also a right angle triangle, and you can easily calculate cos theta and sin theta here. Now what is going to be cos theta? Cos theta is always going to be based upon hypotenuse. Now what is going to be base here? That is BC upon, yes, BD. So which means now BC is going to be the base and BD is going to be the hypotenuse. So you can easily calculate the value of BC from here, that is going to be BD cos theta. Now what is the value of BD? That is Q. So I'm just taking modulus because we are talking about the magnitude only. So that is Q's cos theta, and similarly what is sin theta? In same small triangle, this is the smallest triangle we are having, okay. So sin theta is perpendicular upon hypotenuse, so which means, yes, what is perpendicular here? That is going to be CD upon BD. So CD is going to be equal to BD sin theta, which is also going to be Q sin theta. So now we have marked the values of BC and CD. Now we have all the values here, so just writing it here. The value of BC, we are taking about modulus of each and everything, okay, because we are talking about the magnitude only. So here BC is going to be, yes, that is Q cos theta, and similarly CD is going to be Q sin theta. Putting all those values in equation 1, you will get your answer. So AD, that is going to be R. Now what is AB? AB is P. Now what is BC? That is going to be Q cos theta whole square. Now what is CD? That is Q square and sin square theta. Now this is A plus B whole square. So you know what is A plus B whole square? A square plus B square plus 2AB. Everybody know that, okay. So this is going to be P square Q square cos square theta plus 2P Q cos theta. Now this value is also written here. That is Q square sin square theta. Hope you know that whole square value. That is, I am just using the simplest of mathematics law. So that is A plus B whole square, A square B square 2AB. I'm just using that formula here for that whole square. Now these two values are having Q square. We are just taking Q square common from here. So which means that is going to be P square, that is going to be Q square. In the bracket there is going to be sin square theta plus cos square theta plus 2p q cos theta. Everybody know that what is sin square theta plus cos square theta, that is always going to be equal to 1. So which means we are just putting it 1 here. So that is p square q square 2p q cos theta, and here our answer r is the magnitude of resultant is going to be square root of, because here square it is converted in square root on the other side. So p square q square 2p q cos theta, that is the answer for the magnitude. But because we are dealing with the vectors, we also have to clarify the direction. For direction we always use tan theta. So in the bigger right angle triangle, which is ACD, calculate the value of tan alpha. Now what is tan? Tan is perpendicular upon base. So which means CD upon AC, which can be written as CD upon AB plus BC. Just put up all those values and this will be going to give you the answer of tan theta as well. So CD is going to be equal to, yes, Q sin theta. Now what is AB? AB value is already given to us, that is P, and plus BC value is going to be equal to Q cos theta. This is your answer for the direction of tan alpha. So this is the derivation, very simplest of derivation of triangular vector addition, and this topic is very important for 10+1 students, and we can solve lot of numericals by that magnitude formula. Okay, so hope you now have the knowledge of the triangular law of vector addition, and hopefully you are doing well watching videos and studying. I know this is very difficult time for all of you. Okay, so obviously online class is not going to be I think I can't say it's very good for students, because I know there is a concentration level problem for most of the students. Okay, but till then obviously you have to, you know what is Stephen Hawking say? Stephen Hawking says the intelligence is adapting to the condition. So be intelligent, adapt to the conditions of online classes. So this is going to be a very important topic for you, and thank you so much for joining, and don't forget to like and subscribe. Thank you so much, and bye for now.